Hey guys, BuildZoid here, and today we're going to be taking a look at this right here. I've really screwed up with the camera angle. This right here. There, now it's centered, so... Okay, well, there's a tripod in the way, so this is... I'm not moving it further away. Let's zoom in. So, this right here, I think I overdid that, but anyway, this right here is, as it says on the board, an Ample. So this is a Elmor Labs single phase 20 amp VRM. And the idea behind this thing is you can use it for powering all kinds of, minor rails on GPUs and motherboards and really anything, right? It doesn't care what it's hooked up to. 12 volts goes in, anything between so the default range on this is 1 volt to 3.4 volts, but you can very easily actually extend the voltage range downwards. I don't know if you can extend it upwards. I suspect that there's an actual hard limit on that. Generally there this already goes up to the limit of what the little buck converter that's on this can do. Also, it does come with a cute little heatsink. That's just adhesived on. So, and it's not like a super strong adhesive. So if you want to replace the heatsink with something better, you can. You have this switch over here. Yeah, I'm just gonna go over all the features at this point, I guess. Here's the thing. I've tried. I don't know how to cover this. So anyway, so we've got these switches over here. Those are for controlling the power saving mode for low current outputs and also the switching frequency. So this can run at 300 or 750 kilohertz switching frequency. Obviously 750 kilohertz. Oh boy, I was off center there. So yeah, so PSM is power saving mode and FSW is the switching frequency. So yeah, and 300 is stock, 750 if you need better voltage regulation, and you have better cooling, right? Obviously, it's going to be more efficient at 300 kilohertz. The 6-pin power connector is optional. It doesn't come with, it comes with a 6-pin, but it doesn't come with it attached, which makes this thing super compact if you're trying to jam it into places where, I've actually managed to fit this onto a GPU such that you can still use the stock cooling system. So, yeah, and we're going to take a look at that. So this is what you actually get. Well, actually, so this is a package I've actually opened and I stole. This should come with a header for these through holes right here. I've stolen that header for other uses, but anyway, you can imagine what a four pin header looks like, right? That's not that difficult. But anyway, so it just comes with a 6-pin power connector like this, and then the Ample board itself. And the idea behind having the 6-pin separate is okay, maybe you actually want to power this off of a 6-pin, so you put the 6-pin in, ta-da. Or you are cool with soldering wires from this to the 12 volts of the board you're powering, right? If it's on a motherboard, you just take a 12 volts from the board. If you're on a GPU, you take 12 volts from the GPU, and you save yourself a power connector by doing that. So yeah, if you need the 6-pin, you have the option to use the 6-pin. If you don't need the 6-pin, it doesn't have it installed already. Because the thing is, if it came with the 6-pin pre-installed, it would be a real pain to pull it off, right? That's a relatively large component. It would takes a bit of it's a relatively large through-hole component. It takes a bit of effort to get those detached. So anyway, so that's what you get with the Ample. In terms of features that you have, so I've already gone over the switch. The potentiometer is for your voltage control. I don't remember which direction it goes in for which direction to turn it for which voltage. But anyway, so that's your voltage control right there. You should, if you're going to attach this to a GPU, you should first power it up without anything attached, because there's no guarantee what voltage this will come with from the factory. So, you can just plug it into a 6-pin power connector, and we're going to turn on the system, which I'm just booting the motherboard here. And then it turns on. You get the little green LED telling you that it's running. If we grab my multimeter, perfect. So everything fits into the frame just right. And then if you measure on the output, you've got output voltage, right? And right now it's set to 1.03 volts. You could set it to whatever voltage you want. And where did the resistor go? Okay, right. So the thing is, as I mentioned, the default voltage range on this is from 1 volt to, and we'll turn it off for that. The default voltage range on this is, and the fault LED comes on when you cut the 12-volt power. It's just, what it does. That's normal. But yeah, so the default voltage range is 1 volt to 3.3 volts. Now, let's say you're trying to power a memory controller on a modern AMD GPU, or a display drive rail on a modern AMD GPU, or something like that. And I'm saying modern AMD GPU because most of those cards have various rails. Like, I think there's a 0.7 volt rail on the Radeon 7, for example. So, you have some very low voltage rails, and it's like, okay, well, this normally outputs only 1 volt to 3.4. That's too much. How would you go about fixing that? Well, you've got those headers over here. So you've got your Vout pin, right, which is just connected to the output voltage. You've got a feedback pin, which is the feedback pin of the little buck converter, so that so you can use that to skew the to set the voltage, higher or lower. You have a ground through hole for, well, it's just ground, so whatever you want to do with ground, you can do with ground there. Though honestly, I think it's kind of redundant because this entire strip over here is ground, that strip is ground. Like, there's a lot of ground on this, right? Then you've got output voltage right down the center here, and then on the back, you've got this C-shaped ground plane, and then another output voltage tab right down center. So anyway, I pressed something on the multimeter. Anyway, if you wanted to lower the voltage range on this thing, as in, say you wanted 0.9 volts, you would just put a resistor across the feedback and the Vout pin, Vout through holes like that, and that's a 10K. I think it's a 10K. I never bothered to learn how to read the color codes. I'm pretty sure that's a 10K. And that should drop us about 10%, because I think the feedback resistor, with the potentiometer turned all the way down, is the resistance between feedback and ground, or feedback and output, is 1 kilo ohm. Yeah. So if we set 10K in parallel, we should be getting 0.9 output voltage. So we're going to check that I did that right. Like, it should be around 0.9 volts now. And obviously, if you use like a 5K, you would get even less output voltage, and you get the idea. So let's turn it on. Now it turns up to 0.92 or 0.9. Yeah, 0.92. I'll call that 0.92. So anyway, so that's how you can get, different voltage ranges out of the Ample, which is useful because, again, there's a lot of cards where the stock voltages are really, really low for some of the minor rails. And some of those rails are very fragile, like memory controllers and display drive rails. Oh, so many memory controllers. Yeah. Very, very fragile things. So anyway, that's what, the functionality of the Ample. Oh, and also I forgot to mention, kind of the coolest feature about this is it has an enable pin. It has an enable through hole. So I can't remember how that's supposed to work. Let's just go to the website for. Oh no, I closed the tab with it. Okay, give me a second. Ample. No, why can't I type? There we go. And it does not mention how the enable pin works. Yeah, it doesn't. On the product page, it doesn't tell you. Like, there's documentation for how it works, but yeah. Anyway, the idea behind the enable thing is like, I'm not sure if you have to enable the enable functionality. Anyway, the idea behind that is that you can use it for power sequencing. Because sometimes you're going to be powering, say, a GDDR5X memory system where you cannot turn on the main memory rail before you turn on the VPP. If the VPP is lower than memory, the memory chips should die, at least according to all of the GDDR5X documentation that exists. The same goes for GDDR6. It also has a VPP rail. And I've already showed off the switches. So yeah, that's the Ample. And it has a 24 amp overcurrent protection. So it really is just for 20 amps, but great for, you can power memory system, like you can power memory with it, you can power memory controllers with it, you can power all kinds of minor rails. So great for that kind of thing. And I do actually have a card here that I've used it on. So we're going to zoom out. And this brings me to the other thing that I wanted to show you. Thermal putty, which I recently picked up. But anyway, like, thermal putty basically is... Actually, let's just get the card. So, no. yeah, this is the thing. I'm getting ahead of myself. I should talk about the ample first. So there's my ample. You can see I have a resistor to reduce the voltage range because I wanted 0.8 something volts. And so this is, I believe, a 6.8K resistor so that I get zero point 0.8 volts minimum voltage or something around zero point 0.8 volts minimum voltage. Like the thing is, there's margin on any rail. It's or most like most power rails will have some voltage margin. So you don't have to be super accurate. You just want to be close enough, and this is good enough for me. Um, anyway, so this is my very old or very old. And technically, it is a 7970 Vapor X3 gig, so it's very old. But it's like this is one of the first cards I've ever repaired, and it's been kind of going through hell since then. So, so when I first repaired this thing, so the problem with this card and what the Ample is, the thing that the Ample is solving here is that there's a rail down here, which is the PCIe/display drive rail, and it normally sits at like 0.9 something, like 0.85 or zero point 0.9 volts. I can't remember exactly. I should have checked a different working 7970, but I couldn't be bothered. So, um, yeah, it runs on something around 1.9 volts, or I mean 0.9 volts, not 1.9. Don't put 1.9 volts into that rail; it will die very quickly. Um, anyway, or more like your core will die very quickly. But anyway, so yeah, that didn't work, as in it literally just didn't turn on when I first got the card. And so my genius solution at the time was to power it off of the memory controller rail because the memory controller outputs a pretty similar voltage. Only issue with that is that then it started tripping over current protection. So yeah, then I fixed that by like stacking resistors onto the current sensing circuitry so that it sees less current than it's actually pushing, and then it doesn't trip the OCP, which, like, that fixed the OCP problems. Not the right way to do things. This would be the better way to do things. You just replace the entire rail with an ample like this. So this is exactly the kind of situation where the ample is super useful. You just have a minor, like this rail is probably 5 amps or something. It's like it's not powerful enough to deserve a very large voltage regulator, but it's just powerful. Like it pulls enough power that you can't use a linear regulator for it. Anyway, also what's kind of neat is I actually managed to jam the ample in here such that you can just about, let's see. Yeah, well, okay, you can't really see it on camera, but I can actually turn that potentiometer with, like, the potentiometer that the ample comes with. I can actually reach it down there with a screwdriver. So, yeah, which is pretty neat. Also, it's set up that it clears the stock heatsink for this card, so we're actually going to run this on the stock air cooler. And yeah, so you like it works like a regular e-power. It's just much smaller, and therefore, if you have minor rails that need power, and you can't be bothered with repairing them correctly, super useful for that. Anyway, so yeah, I guess let's take a look at the other thing. So the other thing that I wanted to show you is thermal putty, which is this white thermal paste looking stuff, except it's not. Like this is basically liquid thermal pad. That's not actually what it is, but like it's thermal putty. It's like Play-Doh except thermal. So this has 10 watts per. So this is some T Global. TGPP. Right, I'll just read off the part number. It's TGPP10 50 grams. So, okay, well, the main thing is TGPP10. So it's thermal putty, 10 watts per meter Kelvin. And the thing that's super, like, it basically is meant to fill gaps anywhere from, I think, 0.1 millimeters. Don't quote me on that. I didn't really care that much about the low range. It might be 0.5. Probably 0.1 would probably work with this. Like it's almost thermal paste. Like it is far more solid than thermal paste. Like it does not like yeah, it's really solid. Like you can see that like it's putty. But the idea with this is high thermal conductivity, and it's meant to fill gaps between 0 point something millimeters and 8 millimeters. So really big gaps. 8 millimeters is huge. So it's super convenient because one of the things that I get super annoyed about is thermal pads. Like, especially with this VaporX heatsink. This heatsink right here has, I believe, a 1.7 millimeter gap between this base plate and the memory chips on any card that you use it on, which is just like or it might be like the gap is just the right size so that like it might be 1.2 or 1.7. I can't remember right now, but basically it's just the right size so that like the nearest thermal pad size, like if you obviously if you use a slightly thinner thermal pad, it doesn't work, it's too thin, and the next thicker pad is too thick and won't compress enough, and you like, because this base plate is part of the GPU core cooling system. Yeah, if you use a too thick thermal pad, it doesn't make contact with the core and you get no cooling. Now, luckily with the thermal putty, you don't need to worry about having the correct thickness thermal pad or how compressible the thermal pad is, because this stuff is really, really soft. It just, like, if you put any pressure on it, it'll compress. So, yeah, it's perfect for VaporX cards because their heatsink is super annoying. And it actually, like, in terms of thermal performance, I ran this card with the thermal putty for like 3 hours in 3D Mark Firestrike with heavily overvolted memory. I think I was pushing 1.65 volts into the memory, or 1.7 volts maybe even. Like, I really like, I can't remember right now the specifics, but I ran it for a while, and the highest like back of PCB temperature that I was getting was like 64 degrees or something, which is like, yep, that's good enough, especially considering that the GPU core was at like 70 degrees, so I didn't have the fan speed cranked super high. Um, so yeah, anyway, we just gotta align the heatsink here. And it is very sticky. So when you're taking the card apart, it actually really doesn't want to come apart. And then, like, obviously it's, piled a little bit tall right now, so we need to push down on it. But this is not like one of the problems if you use too thick thermal pads and you just brute force the heatsink on anyway. A lot, like, you can sometimes flex the PCB to the point that you break stuff. With this stuff, you just kind of have to evenly, push it down, and like it'll compress, which is super convenient. Like, no more what thickness is this thermal pad supposed to be? Is my thermal pad? Because the thing is, some of the heat sinks will be designed so that they're like, the thermal pad is supposed to be 1.5 millimeters, but it's also supposed to compress like 30% or something. And high-end thermal pads generally are very, very stiff, unless you get like some super, super expensive ones. And so, that gets super obnoxious where it's like, oh, my thermal pad is too stiff for the card that I'm using, like for the heatsink on the card. And you like, I've broken cards with too thick thermal pads. I mean, I only did it once because then I was like, oh well, that was really stupid. We're never doing that again. But yeah, like if you use the wrong thickness thermal pad and they're not squishy enough, it breaks cards. This stuff, on the other hand, uh, I don't care. Like, I just dab a gob of, thermal putty on the memory chip. That look like, the thing is, it's really hard to gauge the correct amount of thermal putty, but I'm sure I'll just get better at that as I work with it more. But yeah, you just put a blob of thermal putty on whatever the hell it is you need to attach a heatsink to, and bam, done. You don't need to worry about it anymore. Right? Like, obviously it's not like, it is sticky, but it's not actual thermal adhesive, so you shouldn't rely on it to like hold heat sinks in place. But yeah, anywhere where it's like, oh, there's a thermal pad that gets bolted down, thermal putty. Like, way more convenient. Um, I'm not sure if it's more cost effective, but like if it's cheaper. But the fact that I don't need to worry about thicknesses is just awesome as far as I'm concerned. Like, yeah. So there's the card. And I think the PCB on this thing is a little bit warped from all the times that I've been messing with thermal pads on this thing, because like, it's been a hell of a time like this card's been through so many different thermal pads, because again, like, the clearance on this heatsink is just completely stupid. It's just not quite anything that I would regularly have. And all, like, it's not a problem if you're using like really cheap generic, 3 watt thermal pads or 2.5 watt, like 2 watt thermal pads. Like, if you have crappy thermal pads, yeah, they're going to be super compressible. Um, but yeah, if you're buying high-end thermal pads, a lot of them are really stiff. And then you try to put them on memory chips on a card like this, and it does not work very well. So, oh yeah, and there's a bunch of mods on the back of the card, but they're not really the point of the video. There's a bunch of capacitors on here that I stole off of a Vega. Not the through-hole ones, like multi-layer ceramics all over the place. Basically, I recently got my hands on some, I finally, got new solder, and the new solder is tin silver copper, whereas I'm used to working with tin copper. So I've basically been just taking every opportunity to do as much soldering as possible, so I learn how to work with the tin silver copper, because yeah, I'm used to used to working with tin copper, which honestly, like, it's wait did yeah, I got it in right, there we go. So yeah, also the amples, just down there under the heatsink, which is really great. So yeah, we're gonna run a little bit of Fire Strike on this thing. So at this point you might be like, oh, Buildzoid, you've put so much effort into this card, is it any good? Yeah, see, the thing is, I was really hoping that when I finally took the display drive rail, right? So when I ampled the rail that I ampled, um, I was really hoping it would fix the memory overclocking problems that this card has. It did not fix the memory overclocking problems that this card has. It still sucks at memory overclocking, and it's on Hynix memory chips of all things, which is like of all the memory chips to be bad at memory overclocking, Hynix is like, that should not be happening, but it is. So yeah, unfortunately, this card's just not very good. The core is not great, but it's I've just been using it as a test card because of that. Like any stupid idea I have, it's just like, let's do it on this. And the Ample was super convenient for this because I have other cards which, I could like I might have a reason to use an Ample on, but this card is like it needs an Ample because it doesn't have its display drive rail anymore. And I didn't want to like intentionally maim a fully operational card just so that I could get the Ample onto it. So it's kind of, which actually it's not even maiming. Like the thing is, another use for the Ample is like, here I'm using it to repair a dodgy card, but in theory, if you're really like, if you're better with the big soldering iron than you are with the, oh right, I didn't plug in the SSD again. So we're gonna have to power down, plug the SSD back in. Up. So yeah, if you don't want to, like, because sometimes the minor rails will have really obscure voltage controllers, right? And you'll be sitting there like, like the part number is 4 digits. You put it into Google, you don't get anything because it's a 4-digit part number, and like there's a lot of things with 4-digit part numbers that aren't what you're looking for, and yeah. Also, this card fan speed is set to the absolute limit. So one, card works, but that really shouldn't surprise you. Like, if you've been following my channel for long enough, you should know that I'm pretty good at making cards turn on. I'm not so good at keeping them running. Anyway, yeah, so this is really depressing. And the thing is, like, if it was at these volts, it would be fine, but it's not. Like, we need that. We need this. And maxed out power limit. Power limit's maxed out. So this is a really old version of Sapphire Tricks because this is the only version that has all the features I need for this card. Anyway, let's just run some Fire Strike, and I'm going to keep talking about the card. And where was I? Right, so, you'll have your 4-digit freaking part number controller, and you'll have no idea what it is. And, well, the workaround is you can just desolder, like, if it's actually, even if it's a linear regulator, you can desolder if it's a linear regulator, you desolder the linear regulator, replace it with an Ample. Really overkill, like mega overkill to do that, but the Ample really doesn't care, right? So yeah, you could totally use it to replace linear voltage controllers that you can't figure out how to volt mod. You can use it to replace, buck converters that you can't find a data sheet for. You don't want to deal with it. It's like a 5 amp rail, and it's like, oh, it's necessary for cold bug removal. Whack an Ample on it, which, the fun fact, the rail that I actually have ampled on this card right here is the rail that you would normally have to volt mod in order to get these things running at, in order to push the cold bug of these cards lower. Or at least I think it is. Like, there's kind of a yeah, no, it has to be this rail, because the only other rail there is like, there's a 1.8 volt rail, and that one doesn't do anything. Um, so yeah, if you have a card where it's like, oh, like 7970s, 7870s, really anything AMD 7000 series, and it's just like, oh, like you can use it basically as like a more like if you're good at pulling inductors, which pulling inductors in my opinion is really easy. All you need is two soldering irons and well, that's basically all you need. Two soldering irons and just hold them on assuming they're reasonably powerful. If they're really weak, then yeah, okay, two soldering irons isn't going to help you, but um, yeah, much, if you if you want to brute force volt mods with it for minor rails, you can. So that's another cool thing about it is just like, yeah, you can use it for volt modding, you can use it for well, just volt modding, that's the main thing, right? But you can use it for repairing cards with missing rails, and you can use it as an alternative to properly volt modding cards as well. And the cool thing, in my opinion, is with the Ample is like, if you just pull the inductor and you do it reasonably carefully and don't break the inductor, um, which like well, I've broken inductors in the past. These days I don't, unless they're through hole, because through hole inductors suck. But really, through hole components in general just suck to pull out of high power draw boards, right? But anyway, so yeah, if you pull the little inductor, then if you want to restore the card back to original condition, you can just put the inductor back on, and it's back to working condition, right? So that's kind of the thing. Is just like this is super convenient in my opinion. Because yeah, and there, card runs Fire Strike. And like again, I've also run like multiple hours of Fire Strike with this setup right here. Yeah, it does that. So that's it failed out of it right at the very end. As I said, the memory on this card kind of sucks. Or the memory controller sucks. Like something memory system related on this card is not doing so great. And the thing is, even if it was doing great, like the core on this thing just isn't very good. I have cards that'll do 1300 on air. This does 1210. And the voltage slider, like, yeah. Also, I've actually tried higher voltage. It doesn't help. So basically, I've experimentally proven that the card doesn't really clock that great. If we check the ASIC score, it's also not great, right? Like 64% is just terrible for a 7970. I think I have some cards that are like 59% even, so, it's not like the worst thing ever. But yeah, like it's not a very strong 7970, but hey, it's been a really like one of the first cards I ever repaired. I've tested power bridge modding on it. I've done a bunch of cap modding on it. I've figured out how to remove the OCP on the VDDCI rail on this, or, well, shift. It's not removed, it's just higher because of the skewed current sensing. I'm using it right now to demonstrate the Ample. So as far as I'm concerned, this card has served basically its purpose at this point, because it kind of sucks. I have stacks of 7970s. And so basically what I'm thinking of doing with this card next is stealing the VRM and using the VRM off of this thing, like the V-Core VRM off of this thing, to power the GTX 1080 FTW, because, well, this doesn't need its VRM anymore. Like, it spends most of its time sitting in a box. I've run out of things to test on it. I'm done. But yeah, anyway, so that's kind of the plans going forward for this 7970 at this point. It's just like, yeah. Like it does work. I have fixed it. I've redone the repair on this card multiple times at this point, right? Like you've got the first time I got it up and running, then it's like fix the OCP, then ample it, but yeah, it's still. And when I say OCP, I mean overcurrent protection. But yeah, like at the end of the day, it's a pretty mediocre 7970. If not even, like, you could honestly consider it even outright bad. Like, I have a bunch of like early reference PCB 7970s that just kind of destroy this thing on clock speeds, on everything really. It's kind of funny with 7970s how the early cards really seem to be way better than everything. Once you get to like the 7970 boost cards, the boost editions, a lot of them suck like really badly. So yeah, and there's no benefit to having a boost edition compared to a original non-boost 7970. So I guess I could show you what the thermal paste spread looks like at this point, now that it's run, right? Just to show you that because the thing is, if you had too thick thermal pads, right, you would see it in the thermal paste that the heatsink wasn't making proper contact. And I guess I can also show you, well, it doesn't translate on camera when you have something that's really sticky and you're trying to take it apart. It just looks like I have no strength, but really I'm just trying not to break the PCB. That's like, I remember taking apart a card and somebody was like, "Oh, Buildzoid's so weak he can't overpower a couple of thermal pads." And it's like, no, I don't want to break the card. Like, it's like I'm being unnecessarily gentle, I feel like, a lot of the time with my GPUs. But anyway, yeah, there we go. Okay, let off. So yeah, it pulls apart like that. And you can see, yeah, pretty decent core contact. Actually, straight up good. Like, I think just because of the way I pulled it apart, like, the thermal paste moved, but yeah. So, thermal putty, pretty awesome alternative to thermal pads if you're lazy about getting the correct size thermal pads. And then the plans for this card is just like steal the VRM, which that's going to be a bit of an adventure because this card uses a 7870 voltage controller. I mean, 82 CHL8228 voltage controller. The problem with the 8228 is this controller right here has a bunch of power saving stuff. Like, well, all modern voltage controllers have power saving features. And the thing is, normally what happens with these controllers, at least what I've been running into with 7870s, is you cut off the VRM and then you have 3 phases running because that's the power saving mode is 3. Is it 3? Or might be even 2 phases. And that's a 5-phase VRM. So you don't get the full 7 phases. So that's my main concern with this thing is just like, will I have all of the phases? I think I can actually recycle the heatsink off of this, which I'm excited about. So yeah, I get to keep the heatsink, put that on a different 7970, steal the V-core off of this, throw that onto the 1080. Yeah, and then amples are cool. It's just that this isn't a very cool card, which, like, I really wish I had used this on a card where it was, like, more worth it, but yeah, it's just like, it's a 7970. Though, I guess what I might do, because I do have a bunch of, like, I have 5 amples, and some of them were sponsored to me, some of them I bought, like, I paid for. But with all of the amples I have, like, what I'm kind of thinking, like, I do have a lot of 7970s, so I might actually do that thing where I just pull the inductor instead of worrying about how to control the chip that handles this rail down here, and then just use the ample for voltage control. If I take, like, when I take those 7970s on LN2, which is one of those things on the endless to-do list of mine that just keeps growing. Like, the hardware manufacturers don't even need to release any new hardware, and my to-do list is going to keep growing on its own. It just does that. I'm really good at that. Anyway, yeah. So, it's kind of that. And since I'm going to be pulling the VRM off of this, I think I might actually do a video showing how I pull a GPU core with my toaster. So, yeah, I guess like, share, subscribe, so you don't miss that. And yeah, so that's it for the video. Thanks to Elmor for actually, sending some of these over. And yeah, you should definitely check out, like, it. I'll leave a link to Elmor Labs down in the description. They're not, like, sponsoring me for the video or anything. They just sent over a couple of the amples, which, like, technically, like, they are something I would have bought anyway, so it's kind of like a sponsorship. I don't know. But it is, like, it's a single phase VRM. There's just not that much you can, like, I like it. So anyway, yeah, like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. And there's also the AHOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. And yeah, both of those help out immensely with running the channel. They allow me to basically make bad purchasing decisions like the 7970 right here. Actually, this is probably one of the very few GPUs that I own that has paid for itself in terms of views. Actually, after I think of all the capacitors and thermal paste that's gone into this thing, probably not. Actually, even the thermal pads. You know what? Okay, nope. Yeah, no, you can keep funding my bad purchasing decisions. Anyway, so that is it for the video. Thank you for watching, and goodbye.